Hi everyone, welcome back. We will study previous two lecture of basic. Now this one is the last one and I hope you enjoying a lot with all tools. So now start the third and last one. The topic is integration. Integration means the process of finding a function whose derivative is given. If derivative is not given, we don't find it. It means generally it is called inverse process of differentiation. Now we write like this: integration of by dx, where y is function. So right here like this, f of x dx. We read it the integral of function y with respect to x. Next one is constant of integration. This one is differentiation. Now differentiation of x raised to power 7 with respect to dx, it means x. So we got 7x raised to power 6. In this case a constant is hidden. So right here d of dx x raised to the power 7 plus c. C is a constant. After differentiating it, we got 7x raised to power 6. Now the another one is theorem of integration. First one is constant and a variable. U is the function of x. So right here integration of cu dx, we always understand constant term taking outside. So right here c integration of u dx, where u is the function of x. U may be anything, but its value varies with x. Another one is integration of sum of different terms or different function. So write like u plus minus v plus minus w dx. We separate all by integrating it like this: integration of u dx plus minus integration of v dx plus minus integration of w dx. If a number of terms increases, then write like same in manner. So all these are basic one. Now the next part. Types of integration. Generally, integration has two types: definite or indefinite. In case of definite, we provide a boundary region where starting from a curve given that where starting from a and ending at b, or maybe its bottom part at a and top part at b. The region between it is comes under integration. So write like integration of f of dx, where starting from a to b, integration of a to b f of dx, where a is lower limit and b is upper limit. Take an example of this. Write like this: integration 1 to 2 x dx. If we integrate, we got x square by 2 and the limit is right 1 to 2 of right side. Then putting like this one: first we take upper limit 2 raised to the power 2 and divided by 2, then minus 1 raised to the power 2 divided by 2. We got 4 by 2 minus 1 by 2, taking 2 as a LCM, and right here 4 minus 1 upon 2, the answer is 3 by 2. And the next one is This one is a part of 4 minus 1 by 2, so right here 3 by 2. And the last one, indefinite integrals. It means limits not provided, maybe a up to infinity, doesn't matter. So the integration of x dx is x square by 2. Now take formulas of integration in case of indefinite or definite. What are valid in case? Number 1, dx. Dx is, if we integrate it, we got x plus c, where c is a constant. Next, x raised to power n. In case of differentiation, we subtract the power, but in case of integration, we add the power. So n plus 1 divided by n plus 1. In case of differentiation, we multiply this one, but in case of integration, we divide it. In differentiation, multiply. Integration, divide. So always remember. The next one is x raised to the power minus 1 dx. It means this one is 1 upon x dx minus log ex. E the base or x is the number, x base raised e. Another one is integration of e raised to the power x dx, that is ex. So remember all these. Another one is integration of e base e ax plus b. It means here is a varying constant a, so right here e raised to the power ax plus b upon a. Another one is integration of ax dx. The answer is ax upon log a base e. Now the trigonometric sin x dx, cos x. Here is x is hidden. Cos x dx sin x. In case of differentiation, we write here plus, but in case of integration, write here minus. So always remember. Sec square x dx is tan x. Cosec square x dx minus cot x. Sec square x tan x dx minus cot x. Cosec x cot x cosec x. This one is a sec x. Right here sec x. Sin ax dx minus cos ax upon a, cos ax dx minus sin ax upon a. Tan x is tan x dx, right here integration of sin x upon cos x, so we got minus log e cos x. Another one is cot x dx, integration of cos x upon sin x, so got log sin x. Next part is integration by part. In case integration of u v dx, where u and v function of x, so first constant, second integration, taking minus, then right here differentiation of second one, differentiation of first one and integration of second one within bracket. After solving this part, we integrate all. So take an example, integration of log x dx. So right here, oh, something is hidden, so again I say that integration by part. Integration of u v dx. So right here first one is the constant, second integration, taking minus, then right within bracket d of, it means differentiation of first one and integration of second one. After solving this, integrate, so got the answer. Take an example, log of x dx. In case log, we write here 1 into x, because directly log not solved, so taking 1. 1 as the second one. Here is this one is u and this one is v. So v integrated taking log as a constant. So right here, then solving it and got the answer. Now the second part is differentiation of log x and integration of 1 dx. Then we got log x is 1 upon x and here is got x. So x cancel out, we got integration of 1 dx. So right here x log x minus x plus c. Taking x is a common and write x within bracket log x minus 1 plus c is your answer. Next one is solution of the previous part, that is first one is on binomial theorem. So where is given x much less than 1. Now putting the first question answer, that is 1 upon 9 root 1 plus x raised to the power 7. We write here 1 upon 1 plus x raised to the power 7 upon 9, or taking upper side of this one, write 1 plus x minus 7 upon 9. Using binomial theorem, 1 plus x raised to the power minus n is equal to 1 minus nx. Here n is minus 7 upon right, so put 1 minus 7 upon 9x is our answer. The next one similarly, here minus 13 upon 11, but within bracket 1 plus 11 upon x, 11 upon 13x, treating all as x. Then we got same formula. It means 1 plus x raised to the power minus n, 1 minus nx. Right here x is equal to 11 upon 13x. So put the values 1 minus 13 upon 11 and the x part is 11 upon 13x. So right here and x cancel out, 13 cancel out, we got the answer 1 minus x is our answer. Next one is 50 under root 1 plus x raised to power 3. So right here 1 plus x 3 upon 50. So directly we got answer 1 plus 3 upon 50 into x. Using formula 1 plus x raised to the power n is equal to 1 plus nx. So got the answer. Next one similarly, we write here 1 minus 13 upon 11 into 11 upon 13x. After that solving it, we got 1 minus x is our answer. Next one is degree to radian. In case of degree to radian, we write here 145 pi upon 180. After solving, we write here 29 upon 36. This one cut by 5 times, 29 5 is 145 and 36 5 is 180. So right here 29 upon 36. We got this one. The value of pi is putting 3.145 and after solving it we got 2.533. C means radian. Similarly, right here 243 and 30 minute. Change the 30 minute into degree by dividing 60. So we got 0.5. Right here 243.5 degree. Then multiply 5 by 180. Always remember pi upon 180 is the value of 0.0175 and 180 upon 5 is 57.3. This means directly multiply and got the answer. So here is 1.35 pi. After multiplying we got this one. In similar case the next one, multiplying this one we got this one. Radian to this 0.102 radian, multiplying 180 upon 3.145. This one is solving right here 57.3, directly got the answer. Same case multiplying here and got the answer. The last one is 1.2 radian multiplying 57.3, we got 68.76 degree. So this one is a basic. Now the part 2 solution, it means differentiation. 1 minus sin 2x raised to the power 3. As we know that in case of variables, we write here, taking an example, dt raised to the power 3 upon dx. Then we write d here 3 minus 1, that is t raised to power 2 into dt upon dx. Similarly put here, first one is 3 1 minus sin 2x raised to power 2 and d remaining one 1 minus sin 2x upon dx. After solving we got this one as a common, and within bracket breakdown of this one, differentiation of 1 minus differentiation of sin 2x, we got 1 is 0 and sin 2x is cos 2x, then remainder is 2x, so 2x is all 2. Here is 3 minus 1 minus sin 2x square within bracket minus cos 2x and into 2, so take it 2 into 3, so right here 6 cos 2x 1 minus sin 2x square. Next one is log e 2 upon x. This one taking as x, then write 1 upon x and again d of dx. So d of dx it means 2 upon x. Put here the values and we got the answer. 2 as a constant to taking outside and x inverse, it means x raised to power minus 1. Now as we know that power is subtracted, so right here x into minus 1, x raised to power minus 1 minus 1. So got minus x square, it means minus 2. We got minus x upon x square, cutting x cancel out, so we got minus 1 upon x is our answer. Next one is d of dx e raised to the power sin x. As we know that e raised to the power x, then we got ex, so right here e raised to the power sin x, and next one is sin x is a differentiation, we got cos x, so cos x e raised to the power sin x is our answer. Next one is d of e minus x upon dx, we got minus e minus x, minus e raised to the power minus x, your answer. This one is lengthy question, so try to understand at least twice so that you understand very well. First one is the differentiation of log under root 1 plus tan x 1 minus tan x. If we taking this one is a x, then our answer is 1 upon x, and then differentiation of next one is dx upon dx. So write like this, 1 upon under root 1 plus tan x upon 1 minus tan x. This one is the log case, and right here d of dx within bracket under root 1 plus tan x 1 minus tan x. This one is a lengthy one. After converting this one, right here 1 plus tan x raised to power 1 by 2 1 minus tan x 1 by 2. 1 by 2 is root value, so right here 1 by 2 1 by 2. Next one is be putting as u upon v, it means u v minus v u upon v square. So taking like this, first constant second differentiation minus second constant first differentiation, we got this one here. Here is a second, it means square. After solving this one, we got like this. Now understand one by one. In first case, we differentiate this one, tan x, that is here is right here 1 minus tan x, subtracting the power 1 by 2, there is subtracting minus 1, it means 1 minus 2, so right here minus 1 upon 2, this one is a power, then tan x difference of tan x sec square x, here is a minus, so taking minus, and the next one is this one is a constant 1 minus tan x raised to the power 1 by 2, and 1 by 2 tan 1 plus x raised to the power minus 1 by 2 into sec square x. Here is a minus sec square x minus sec square x, taking it outside, and right here like this, sec square x by 2 and 1 plus tan x 1 by 2 1 minus tan x 1 by 2 plus 1 minus tan x 1 by 2 1 plus tan x 1 by 2. 1 by 2 it means root, I don't take as a root, I write like 1 by 2 as a power. So next one is taking LCM in this, cross multiply, this multiply to this one, this multiply to this one, and this multiply to this one. So right here 1 plus tan x 1 by 2, 1 plus tan x 1 by 2, 1 minus tan x 1 by 2, 1 minus tan 1 by 2. Here is multiplying together 1 plus tan x 1 by 2, 1 minus tan x 1 by 2, and outside 1 minus tan x. After multiplying we got 1 plus tan x plus 1 minus tan x. Tan cancel out, 1 1 2, so 2 and 2 cancel out, and the denominator side 1 minus tan square x, we got sec square x. So right here sec cancel out, sorry this one is not taking, we don't change it, actually we try to cancel out this one tan. So right here under root 1 minus tan square x, because sec square x is equal to 1 plus tan square x, so it not possible, that's why this one is cancel out. So take under root 1 minus tan x upon 1 plus tan x, and this one is under root 1 minus tan square x 1 minus tan x. Here is this, after separating we write here under root 1 minus tan x, so this one cancel 1 minus tan x. Now the another one is, here is a plus, here is a minus, so multiplying both together we got 1 minus tan square x. Already I have under root 1 minus tan square x, so this one is a square form, so right here 1 minus tan square x square, so root is cancel out, so right here sec square x is also write 1 plus tan square x and 1 minus tan square x. Here taking minus as a common, because this one is our answer. Now the last one, that is differentiation by parts. Here is x is equal to p t raised to the power 4 by a t square. Now differentiate x with respect to t, dx upon dt, right here p as a constant, d t raised to the power 4 upon dt, we got here p 4 d tq, directly write tq, so here is 4 p tq. Next one is by at square, so we got 2at, and dy dx, we write here dy upon dt into 1 upon dx upon dt, putting the values of this 2at upon 4 ptq, t cancel out, t square, and 2 2 is 4, so right here a upon 2 pt square. These all are the basics, so today I am solving the basic parts. The application of this one applicable everywhere when you study physics. The next is unit and dimensions. It means the first chapter of your book, which is the most important part. The application of that one is also available everywhere. It means using any times. Unit and dimension is also one of the best part to our study point of view. I hope you are enjoying a lot to this one. Now I am covering the next one as the first chapter of your subject. Thanks for watching.